Hi guys, so I've been pretty let down by technology today. So my usual software is down. So here I am with a camera and a piece of paper with a question on it. Question number 20 for lovely Humera. So here we go, let's try this. This is a Pythagoras, a trigonometry in 3D question. So we're going to have to think Pythagoras, we're going to have to think SOHCAHTOA, and we're going to have to think sine and cosine rule. So let's do it. My question says the diagram shows a pyramid with base ABC. So I've got A, B, C. That's the base, the triangle there. Then it's telling me that CD is perpendicular to both CA and CB. So this is your CD. And it forms a 90-degree angle here with CB and a 90-degree angle on the other side with AC, like that. It's then telling me angle CBD is equal to 39 degrees. So CBD, this angle here is 39. It's telling me angle ADB is 45. So ADB is 45 degrees. It's also telling me angle DBA, so this one here is 55, and it's telling me that BC, this side here, is 18. And it wants me to calculate the size of the angle between the line AD, which is the one on top here, and the plane ABC, which is the base of the triangle. It wants me to give my answer correct to 1 decimal place. So what I'm going to start doing, as I would in any of these questions, these 5-mark questions, even if you're completely lost, just start by working out what you know. So I see probably the most easily used information is in this triangle here, DCB. So if I take this out on its own, so this is D, this is C, this is B. I know this angle here is 39. I know this side is 18. And I'm going to try to work stuff out and annotate my diagram, see if I find some meaningful stuff. Cool. So I've got a right angle triangle, which tells me I need to use either Pythagoras or SOHCAHTOA. I can't use Pythagoras because I don't have two sides. That means I have to use SOHCAHTOA. So I'm going to write my SOHCAHTOA here. SOHCAHTOA. And then I'm going to see what I can use. So I'm thinking, let me work out as much as possible so I can work out DC and I can work out DB. I'm going to start maybe with DC, just a random choice. So if this angle is my target angle, as I like to call it, if I want to work out DC, DC is the side opposite to it, and BC, which is the side I know, is the adjacent to it. So this means, because I've got O and A, I'm going to be using TOA. So I'm trying to work out the opposite side. I'm trying to work out DC. So I cover the opposite like that. And that basically means that I have to do tan of the angle times adjacent. So I'll do that. So my opposite, which is DC, is equal to tan of the angle times the adjacent, which is 18. So I'm going to type that in my calculator. So tan of 39, close bracket, times 18. That gives me 14.58 to 2 decimal places. I'm not going to round too much now. I'm going to do my fine rounding at the very end. Okay? So I can now annotate that DC is 14.58 there on the diagram. Great. So we said let's work out BD as well. So we get some stuff on top here. We get more information we can carry forward and use. So in the same triangle, because I'm not trying to work out BD, I'm going to take these off. So the O and the A. And start again. So my target angle is the 39 degree, and with relationship to it, BD is the hypotenuse and BC is the adjacent. So because I've got A and H, I'm going to use K. So I'm working out the hypotenuse. So if I cover it, it tells me that I have to do adjacent divided by cos of the angle. So if I want to work out my BD, I'm going to have to do my adjacent, which is 18, divided by cos of the angle, which is 39. So if I type that in my calculator and I'm going 18 divided by cos of 39, I'm going to get 23.16, and that's rounded again to 2 decimal places. So I can annotate on my drawing that side, the BD is 23.16. Nice. So let's now look at the triangle on top. I think we've exhausted everything we could have done with this one. So let's look at the one on top. So if I draw it like this, and I've got A, D, and B. This angle here is 55. This angle here is 45. And I can definitely work out this angle here as well, just because I can and I want to show off angles in a triangle. So if I add these two together, I get 100 degrees. Then I do 180 minus 100 and I get 80 degrees for that one. And I also know that side DB is 23.16, and that's annotated there. Nice. So I've got this triangle. It's a scalene, so I'm thinking sine or cosine rule, and I've got 3 angles and a side. Now I know that the sine rule operates with opposites. Okay, and I want to get as close as possible to here, the bit that interests me, so the line AD, right? So I can work out the line AD. Like that, using the sine rule. So let's apply the sine rule. And we've got my side here, which is 23.16, divided by the sine of the angle opposite it, which is 80 degrees. And that's equal to AD divided by sine of the angle that interests me, which is opposite it, which is 55. Now if I want to make AD the subject, I'm going to multiply both sides by sine 55. So in my calculator, I'm going to type 23.16 over sine 80 is equal, times, because we said we're going to times both sides by sine 55. And this is what I type in my calculator. There you go. So I'm going to do that. Got 23.16 divided by 80 times sine 55, and I get 19.26. So AD is equal to 19.26, like that. Okay, so I've got my AD, and I can now, I think I'm ready to work out the angle. So now what I'm looking at is I'm looking in this triangle here, ADC, and this is the angle I'm trying to work out, because this is the angle that the side makes with the plane or with the base. Okay, so if I isolate that triangle here, so that's my triangle ADC. I've got my AD, which I just worked out is 19.26, and then I've got my DC, which is 14.58, and my target angle would be this one, which I'm trying to work out. So let's label this one. If this is my target angle, angle A, opposite it I've got 14.58, and the hypotenuse is 19.26. So that means I'm going to have to use sine. So the last one we're going to use is this one, sine. And because I'm working out the angle, if I cover the S, it's telling me I need to do opposite divided by hypotenuse. So sine of the angle, which I'm going to call X, is equal to opposite, which is 14.58, divided by hypotenuse, which is 19.26. Now, because you're working out an angle in your calculator, you should now type shift sine. So it's going to come up as sine minus 1 and then a bracket. And then you type the fraction with it here, 14.58 and then 19.26. So if I do that in my calculator and I go shift sine, fraction, 14.58 divided by 19.26, I'm going to get 49.2. And that's my answer, believe it or not. So we're done. 11 minutes later, we've got our answer, but that's because we've been talking through it and not because it's super long. Great. So I hope normal program resumes tomorrow. I'm going to try to get a few more done for you guys. Definitely going to try to do number 22 for Chimera. Until then, happy revision. Bye.